What's up, everyone? Welcome back to the Routing Loop. I'm Matt Lewis, Solution Architect for AWS, and we've got Tom Adamski, also a Solution Architect for AWS. Hope everyone's doing well. It's been a little while since I've been on streaming with you folks. Just came back from a little vacation, which was fun. So I'm a little rusty, but how you doing, Tom? How's things?
Yeah, I'm good. I'm good. I was about to ask you if you're feeling rusty, if you're like dusting off the cobwebs to get into the stream.
I'm feeling good. We actually changed our flights back. I was flying back last Friday, and the weather was so good, so we decided to fly back on Sunday. But that means we got back Sunday night, and I started work on Monday morning, and that's always tough.
Yeah.
So you don't get any kind of downtime to do washing and unpack and all that kind of stuff.
Yeah.
So right back into it. But no, it's all good.
Are you one of the people that unpack straight away as soon as you arrive back from a trip, or you're just leaving your luggage lying there for weeks?
I'm a mix. So I feel like I feel like I take my essentials out and then zip up my bag, and then the roller bag just kind of wheels around my place for about a month, and there's like I'm like, oh, where's my my toothbrush? And so you're living out of your bag for like another week before you eventually say, okay, this is enough. I need to put this stuff away. So
Yeah.
I
As long as
feel like I'm like a hybrid.
as long as it's not a sandwich in that bag, you should be fine, right?
Yeah, yeah, exactly. And speaking of hybrid, so we're doing hybrid DNS with Route 53 Resolver. And today, Tom, I think you're going to do some setup and a bunch of whiteboarding. Did you do any slides, or are we purely whiteboard today?
We got no slides. So this is one of the sessions that we are doing based on the feedback. So we are looking at your feedback in the survey. So there's a survey link on the routing loop page, top right corner. So the routingloop.net, and then you have a survey where you can provide feedback on the session that you've just watched, but you can also provide info on what else would you like us to talk about. So there was a lot of requests. Hey, we want to talk about Route 53 Resolver. Tell us about hybrid. So this is a little bit spontaneous, where we're just going to go and talk about Resolver and hybrid scenarios, and then we got a demo environment that we'll just start setting up from scratch. And yeah, whiteboarding and live demos.
All right, that sounds great.
Yeah.
And I think the hybrid story is something that is important to a lot of folks, just because we live in the cloud. We're always doing AWS things and VPC and everything else, but I don't know what the percentage is. We could maybe ask Gartner or something like that. But the percentage of companies that actually have stuff on premises, that have things in a closet, have things in a data center, or have applications that are pre-existing, pre-cloud. So this kind of stuff is still very relevant for a lot of people. See Dominic's comment about the kids' school backpack mystery. I remember once when I was at college or university, as we call it back in Australia, and I pulled out my sandwich at lunchtime and took a bite, and I was like, this one doesn't taste very good. And it was the one from like last Friday or something. Same ham sandwich I'd make every day, but whoops.
I think this is a
My fresh one
childhood.
was in the backpack.
Yeah, that's like a childhood classic, right? When you find your
Yeah, yeah.
sandwich and you go, "Oh, there's worms in it." Uh-oh.
Yeah, yeah. It's a little mold. It's a little green. I don't remember putting mustard on this thing.
Yeah, yeah.
Hey, Tech First, how you doing? Good to see you again. All right, well, should we get in here?
Yeah,
Are you
let's
ready?
do it. Let's do it. Ready to
All right.
share. Um,
Okay.
right. So I think we're gonna start off with a whiteboard and just going over the environment that I have. It's gonna be super simple. And this is the environment we also recommend when we have new people joining AWS and they want to get involved in networking and they want to learn about DNS forwarding and hybrid configurations for Route 53 Resolver. This is the kind of environment we would recommend they build. Okay, so this is what we're going to have.
What are you using to whiteboard here today, Tom? I'm curious. What's your
Uh,
setup look like?
so all I have is just a Wacom pad. This is
Okay,
probably like
okay.
50 bucks from Amazon. I like my things simple. The less technology in the thing, the better. So no iPads. And I also like when I draw, I can look at the screen. So I can,
Yeah.
look at you guys and then draw VPCs. If I had a iPad, I would be like my head down the whole time.
Yeah. Yeah. That's
Okay.
true. A lot of people spend half the stream looking at the top of my head while while I'm drawing things.
Yeah.
Not a great look.
Okay. So we have a workload VPC. Um, that's going to represent anything in AWS. And that is using 10.0.0.0/16 range. And we just have a EC2 instance in here that will be our client, and we'll be doing the DNS queries. I'm going to use Transit Gateway, so TGW. If you don't know what TGW is, it's just like a distributed router inside of the region. You can connect thousands of VPCs to it, and it operates on the basis of attachments. Each attachment is kind of like a like an interface to the VPC that lets the VPC talk to everything else. And then I don't have real on-premise, right? So it was much easier to just have another VPC and call it on-premise VPC. And that
we do have some real on-prem stuff in one of our labs somewhere, right? Where you could really jump in there. But that means you've got to start configuring Cisco routers and dive into physical server things.
Yeah. But maybe we can do that one day as well. We can actually show that setup of Direct Connect, because that's usually a mystery.
That'd be cool.
But for the sake of just pretending there's an on-premise environment, this is good enough, right? This is going to use an attachment as well, just a VPC attachment. But in real life scenario, this would likely be something like a Direct Connect or VPN, and the on-premise would be your data center. And inside of your data center, you might have a DNS server. So this is our on-prem DNS server. This is running bind. And if I remember its IP address, it's 192.168.0.7. So all of this is a fake on-prem, but it will be in the VPC. So just imagine this is not really inside of the VPC. Okay, and then the on-prem is hosting a private domain, private zone, example.internal. And the initial name of the game is going to be to figure out how we can have the EC2 instance be able to resolve records in there. I think we have www.example.internal, we have mail. It's kind of the standard stuff you might have inside of your on-premise DNS server, with all of these pointing to different IP addresses in the 192 range. Okay, so let's go a quick roam around in the environment we have. So here are our instances. So this is our workload instance. This is our on-premise DNS server, 192.168.0.7. Okay, so I got the IP address right. Let's have a look at the VPCs very quickly. And I have just the workload VPC 10/16, on-premise VPC 192.168, and then I'm plug them both to a Transit Gateway. Super simple. And then we can connect to our on-premise DNS server, which is not really on-premise again. And I'll show you the zone we have configured on it. So it's actually running bind, which is an open source DNS hosting software. So I can just
And what are you using here to access your instance, Tom? Do you want to tell people about that? Because normally you'd use like an SSH client and kind of go in through that way.
Yeah, it's actually a good point. So in each one of those VPCs, and I'm going to draw it and then delete it so it doesn't muddy our water, but it's a good sidebar. I actually
You can
have
delete with the Wacom tablet. They let you do that?
No, yeah.
Just teasing, man. Just teasing.
Yeah. So this is EC2 Instance Connect endpoint that I deploy inside of the VPC. And this can talk to the EC2 instance completely privately. So I set up my security group to make sure that there's private communication happening here. And me as a user, I'm opening up a session to the EC2 Instance Connect service, kind of managed by AWS. And then that can transport my traffic privately through the endpoint to the EC2 instance. So that EC2 instance doesn't even need to have a public IP address, doesn't need to have access from the outside. I can, through the browser, connect to it privately. It's just one of a few ways. There's also Systems Manager, Session Manager. It's another option that kind of operates in a similar fashion, where I can on the fly just use a browser-based session to the instance. So that's
and you actually like Instance Connect more than Session Manager, maybe? Just easier, or just naturally what you gravitated towards? Or
yeah, I kind of use both. I keep switching between them. Because we could connect, like when you do connect to the instance, you actually have a session manager as an option. The difference is with session manager, you have to have a role applied on the instance that allows it to talk to session manager. And I would say session manager is the more feature-rich option that has, ability to connect to not just Linux-based instances, but also Windows. But it does require an agent to run on the machine, whereas EC2 Instance Connect is more of a network level kind of option to have a managed way to get into the instance over SSH. They're both pretty
You think
easy,
there's
to be honest.
any thoughts on Tech First's comment around SSM endpoints where you need EC2, etc. endpoints?
Sorry, can you repeat the question, Matt?
Tech First is saying I think it's cheaper than SSM endpoints where you need EC2 SSM messages or two endpoints. I think it's maybe a typo in there, but
yeah, actually, from
like,
an
is there a
endpoint,
price difference
yeah,
between the
from an
two? I
endpoint
guess.
point of view, I think you have to have an extra endpoint. Actually, with Session Manager, you can have an endpoint if you want to have it privately communicating. So both options have an endpoint. If I remember correctly, you actually, Tech Field might be correct that you might need two endpoints for the systems manager. I would have to double check. So there could be a little bit of an hourly cost difference. And I can't remember if we charge for the EC2 Instance Connect endpoint actually, because it's pretty limited to just like very few use cases. I would have to double check. Yeah, so there might be some price difference. A good call out.
Okay, I think. Oh, thanks, AE. Appreciate that. I think maybe we're getting distracted here, but there's probably a session, or there's probably a session's worth of content in connectivity to your environment. Maybe that we could couple that with some observability and connectivity or something in a future session. That
Yeah,
could be cool.
yeah, I think that's a good call out too. Yeah, if
All right.
folks, if you are interested in any of the sessions, just pop it on our page, submit your feedback, and give us suggestions. We do check them. If there's going to be any, yeah.
I was just going to say, do we have a working feedback thing on the routingloop.net now?
Yeah. Actually, yeah.
That's amazing.
Let me just show you. So this is the routing loop page, and there's a feedback page here. You can click on it, and then it'll take you to the survey, and you can fill out the survey. Give us 5 stars. Leave us a joke. Tell us what you want to see. We do look at it. Okay. Going back to DNS. So I have this DNS server here. It has a zone, example.internal, and there's a few records in that zone, www, mail. But this lives on premise. So if I'm going to connect to this EC2 instance now that's in AWS, and I'm going to use EC2 Instance Connect as well.
Hey, Tom, just real quick as a sidebar, Sandkit said he joined late. Do you just, not just for Sandkit, because I know a bunch of other folks may have joined late. What are we working with here?
Okay, so we're working with hybrid DNS. So right now we're just going over the setup of the environment. We have on the left-hand side the VPC in AWS with an EC2 instance connected to a transit gateway, and then we have another VPC on the right-hand side pretending to be on-premise environment. You can see the IP space here. And the VPC that pretends to be on-premise data center also has a DNS server hosting a private zone that's only visible right now to this DNS server. And the first thing we will try and do is somehow allow this EC2 instance to be able to resolve records in this example.internal.
Okay, awesome.
Right. So if I do a dig, so dig is like a tool to do a DNS lookup on maybe mail.example.internal. That's not going to work, right? I have NX domain that it can't find this domain. It's not available anywhere publicly. So let's zoom in a little bit closer on what is actually happening when that DNS query occurs. Right. So inside of our VPC, maybe let's do blue for like more DNS components. We always have Route 53 resolver. So that is sometimes called a .2. The reason why it's called .2, or there's also multiple names. So Route 53 resolver is the resolver is the most recent name that we kind of use it right now, but it used to be called Amazon provided DNS .2. And what happens by default, if you don't make any changes to your VPC, if I do a DNS query from the EC2 instance, that DNS query goes to this .2 IP address. And then we have infrastructure behind Route 53 resolver to deal with your query. So if you're sending a query to a public domain will do recursive resolution, talk to all the servers publicly, and then give you the answer if the domain actually exists. Because you're doing a query for an internal domain that doesn't exist anywhere out there in the public world, so you're going to get back an empty answer, non-existent domain. So the challenge is now, okay, this is all private. We're not going out to the internet. We don't want to go out to the internet. How can we make this instance be able to resolve the records in that domain? So there's another option in DNS where I can specify the DNS server that I want to do this query against. So rather than using the default, which is, you can see here, the server that responded to our query is the .2. And Matt, let me know if this is too small and I can zoom in even more.
That's better, actually. Yeah, right there's good.
Okay.
Unless anyone else wants to comment in the chat, if it's too small, too big, we can change it around.
Okay, so we've had a question. We had an answer from 10.2, so this is the RAD53 resolver. But I can specify the actual DNS server as long as I can reach that server, right? So here we know that the server on premise is 192.168.0.7. Routing is configured, so I should be able to, like, I'm going to ping it first, so see if I can actually get to it. So I'm going to send an ICA ping 192.168.0.7. So I can ping that server. So I should also be able to send a query as long as any security configurations in the path allow me to send a DNS query to it. I should be able to just target it directly, 0.7, and that works. So now I send a request bypassing Route 53 resolver. Right, in my configuration, I said instead of using the native DNS resolver, I want to send this query straight to this IP address, and this already has the answer because it's actually hosting that domain. So this was the authoritative server that responded back and said, okay, a mail was 192.168.1.12. Now, what I've seen some customers do, and that's not a good practice, is to try and set that up kind of in production. So you can configure your VPC to change the default DNS from being the resolver to being something else. And I've seen some customers go, actually, you know what? I want the spine server to be my DNS for everything. So I'm going to go in and reconfigure my VPC options. It's in the DHCP options of the VPC to change that default DNS server from being .2. I don't want that anymore. I want it to be 192.168.0.7. So that anything that's provisioned in this VPC is going to start using 192.168.0.7 as the default DNS for all of its resolution. So that will technically work. The reason why it's a bad practice is, imagine there's an issue with the connectivity to on-premise, or your server on-premise fails, right? So this bind server goes down, or connectivity to on-premise goes down, but you configured all of your resources in AWS to do DNS queries directly against this IP address, you now completely lost connectivity, right? So even though this EC2 instance might be going to, I'm going to www.amazon.com, I will not be able to resolve that query because I'm not using the resolver. I was using an IP address that was on premise, and I now lost connectivity to it.
And I think one of the things just to call out here, that right-hand attachment looks pretty simple and direct in this diagram, but it may be a direct connect going over a WAN connection, which has a bunch of latency and could have a backhoe that digs up a fiber. And if you don't have resiliency and a whole bunch of other stuff on that path, you could be in for a world of hurt.
Yeah, I think that's a really good call out as well, that the latency is a thing you should consider here. So its availability is one huge component, right, of doing this model. Latency is another one where you're something that you could have gotten an answer like in milliseconds or less. Now you're having to wait maybe 10, 20, however far this DNS server is, maybe even further, right? Maybe you're having to wait 100 milliseconds to get an answer or more. So it just becomes an additional delay to you actually getting an answer, plus the risk in availability. So that is.
And again, in this hypothetical scenario where that right-hand attachment is not a transit gateway attachment, it's a direct connect going to on-prem via another data center or something else.
Yep. So the big call out here is don't do this, right? Even if you have a requirement that you want your on-premise server to be able to do all of your DNS resolution, you should still always send the query to the Route 50 resolver. And then what we'll do is we can add rules here to decide what we want to do with those queries. Right, so we always want the queries to go to Route 53 resolver. That's the best practice. And then this extra step is, hey, let's attach some rules, and those rules will govern what's going to happen with certain types of queries. And some of them we may want to forward to the on-prem DNS server, or maybe all of them, except for, if there's a private hosted zone, which is like a DNS zone that you can attach to a VPC, that will take priority and doesn't need to be forwarded anywhere else. So we're going to do that just now. So we'll set up some rules and we'll set up forwarding so that the EC2 server can still talk to the Route 53 resolver, but then the query for only for example .internal is going to get forwarded to on-premise.
So a couple of questions here. One from Sankit. And I think you're going to get there. Oh, whoops. Sorry, I think I clicked the wrong one. Can we use this approach for replication or disaster recovery scenario? I think you're going to get there. So I think the scenario you were talking about on using the on-prem resolver, you're going to talk through what the better scenario would be from a disaster recovery scenario as well.
Yeah, so that's exactly what I'm recommending. So don't bind yourself, pun intended, to a server on premise for all of your DNS resolution, right? If the setup you should have is forward all of your DNS queries to Route 53 resolver, and then let the resolver decide what should happen with that query. Maybe you're resolving a public domain and it can just give you the answer. And then if it's something that's on-premise, example.internal, set up forwarding rules to forward those queries to on-premise to the server that actually will know about it. So that way, if there's an issue with that server, the only DNS resolution you lost is for that on-premise domain and not for everything else, right? If you link yourself too hard to, or it doesn't have a name for it, I'm losing.
Strictly couple.
Tightly coupled, yes.
Tightly couple.
Yeah, if you tightly couple
Tightly
yourself
couple.
to that DNS server on premise, you're going to have trouble when there's any issues. So you definitely don't want to do that.
So a few more questions, but Tech First saying it adds data transfer cost to transit gateway and direct connect VPN. I think that's true, but we're talking DNS true as well. So it's probably not a lot of data.
Yeah, it shouldn't be a lot of data. That should be peanuts. Yeah,
compared to, but it is true. You are paying for it though.
Yep. Yep.
And lastly here, if DNS has multiple IP addresses, which IP route will Route 53 resolver use first?
So the Route 53 resolver always has one IP address, and it's not the one IP address is ultimately you can think about it as like a virtual IP address for DNS resolution inside of VPC. So it's not a single thing inside of the VPC that's dealing with your DNS queries. It's a distributed system, but it's represented as a single .2 IP address. So when we see requests to the .2, we know it's a DNS resolution, and there's a whole infrastructure dealing with that connectivity. So you don't have to worry about availability inside of the VPC. For forwarding, if you have a single server on premise, sure, if that single server on premise fails, you won't be able to resolve example.internal, right? So you want to think about availability on premise, maybe have multiple on-prem servers, and I'll show you options to send traffic to multiple servers, but then it's up to you to figure out that availability there.
And last comment here from Dinesh, who's saying, I trust my on-prem system, which can run bind and has an uptime of 500 plus days. I think it's not really, in this case, correct me if I'm wrong, Tom, it's not really about the uptime of the system on premises, it's really the connectivity to that system. Correct. And when you're going over long stretches, you are running an availability risk because of the hops in between you and your system, right?
Yep. Yeah. That's a good call out. So it's the distance, it's the availability of all of the components in the path, not just the server itself. I would assume, yeah, bind is pretty solid. I can imagine it running for like thousands of days. But it's more about the fact you're unnecessarily forwarding a request that could be resolved locally, right? So the rule of thumb is forward only what you need to on-premise. Let resolver deal with all the other queries. Okay. So
I saw an article once about a light bulb that was the officially longest running light bulb on the planet, and apparently it was made out of a bamboo filament in the staircase of a New York City building somewhere. I don't know if that thing's still running, but if you leave a system alone in a closed environment, things can run for a long time, right? I think is what the point is.
Yeah. Don't touch it if it's not broken, right?
Right. Exactly.
Okay. So what we're gonna do is go into Route 53. And actually, there's a Route 53 resolver, but we can just go straight to Route 53 here. And I have a pretty simple configuration in this account. I have some hosted zones here. We're not going to look at them right now because they're hosted zones that exist in AWS that we can attach to the VPC. So for our use case of having the EC2 instance trying to resolve something on premise, right now they're not relevant. If we have time, we'll touch on them, but right now they're not super critical. So the thing we need to do first is to be able to send queries to on-premise is create outbound endpoints. So in the resolver section, you can see there's a bunch of different options here, inbound endpoints, outbound endpoints, rules. So first thing we need to do is create an outbound endpoint. And this is going to be the infrastructure required for Route 53 to be able to send queries to on-premise. So we're going to call it my outbound endpoint. We have to specify in each VPC, in which VPC will this endpoint exist. So I'm going to put it in the workload VPC. I need to give it a security group, specify if it's v4, v6 dual stack. Sorry, Alex, we're keeping things v4. We have the option here to just use regular DNS or do DNS over HTTPS. So if you want to encrypt the DNS communication from the outbound endpoint back to on-premise, that's an option. I'm not going to do that. And then we need to specify the subnets. We only have, I'm using a single AZ, don't do that in production, but for the simplicity's sake, I'm just going to pick two subnets that are in the same AZ. And create the outbound endpoint. So as this is creating, here's what we've done. So we've created an outbound endpoint, which is ultimately a network interface. Outbound endpoint. ENI. That's going to have some IP address from my VPC. So 10.0.0, we'll check what that is in a second. And that is something that the Route 53 resolver can use to send queries that need to go to on-premise. So you can think about it as just an interface that's going to be used for forwarding outbound queries. So I don't know what's the best way to maybe draw it, but imagine the resolver, after it's evaluated what it needs to do, it can send the query up and then use it to get out and route traffic because it will appear from the IP address of that ENI. Okay, so let's see what's going on here, if it's still creating. Still creating. The other thing we need to set up while this is creating is going to be a set of rules. So this is just infrastructure. We now need to configure these rules to specify what is it that we want to do. And the rule I'm going to create will say that if you're seeing anything ending with example.internal, the rule is going to be forward. And then via the newly created outbound endpoint. And then the destination IP address is going to be my DNS server. So 192.168.0.7. So what the Route 53 resolver will do is as these queries come in, it will evaluate each query and look for queries ending with example.internal. So www, mail, anything ending with example.internal. The rule here is going to be instead of using the regular behavior of forwarding to trying to do the recursive resolution on the public side, I want the Route 53 resolver to forward this query via the outbound endpoint to this IP address. Okay, so the endpoint is now operational. We can have a look at it. you can see here it's got two IP addresses, 10.0.1.3.2.1 and 10.0.8.95. One thing to call out here is each endpoint can deal with 10,000 queries per second. So if you need to increase that capacity, first of all, I'm going to show you in a second some of the CloudWatch metrics that you get, so you'll be able to see how many queries an endpoint is dealing with. But if you're getting close to 10,000, you need to start adding additional endpoints and kind of sharding your traffic. It's quite a high number, so I haven't seen many customers have to do that, but it's worth knowing that
Some
it's there.
folks do hit that limit. Surprisingly, that's a massive amount of requests. So let me know when's a good time to take some questions, Tom. I don't want to break your thought process.
Yeah, we can do that now. I'm going to start creating. So you know what? Maybe I'll create the rule, and while it's creating, we can take some questions.
Okay.
So
Perfect.
this is we'll call it the example internal rule. So this is going to be a forward rule, which means we will want to forward the queries with a particular ending. Here is the domain name. So here is when we need to specify example.internal. Hope I don't typo, example.internal. This is the domain name that we want to forward, or the top level domain that we want to forward to. And then the rule will be applied to a specific VPC. Ignore the fact that the on-premise VPC is showing up here. It's in the same account, so it shows up here, but we know on-premise is pretending to be on-premise, so we can't use it. So we will deploy that rule against the workload VPC. And we can specify the outbound endpoint that was just created. And then we need to specify what is the target IP address that we're forwarding to. So it's going to be 192.168.0.7 was my DNS server on premise. I can only use regular DNS. I haven't enabled this for DNS over HTTPS. If I did, I would be able to add an SNI if I needed that. But we're keeping things simple for the demo. And that's pretty much it. So that rule is now being implemented. We can take a moment for questions, Matt.
Yeah, let's do it. So, all right, Sankit and Mr. Soroka are asking about firewall and ports. So Sankit was saying make sure we have an open port on the firewall. I guess that's a fair comment, right? If you've got a firewall on premises, you need to
For
have that.
sure. Yeah. If you have a firewall anywhere in this mix, right? If there's a firewall, if there's a security group, because I configured a security group around this endpoint. I configured a security group around this instance. There could be rules that are configured on the transit gateway where you have a third-party firewall and AWS firewall somewhere in the path. There could be, firewalls on premise, so totally valid. You need to make sure that you can connect. So that's why this initial test of that I did on the instance, where I said, hey, if I try and resolve directly against the IP address I'm trying to get to, and that works, I'm pretty confident the firewall is going to allow it, right? So that is going from the EC2 instance, but in a second, that's going to be going via the endpoint. And I use the same security groups, and it's in the same VPC, so it has the same routing behavior. So that is a good kind of litmus test to confirm, is that DNS resolution working when I try to connect directly to the remote server on premise?
Okay. And I think that's the same with what do you have in the security group, or what does the security group configuration look like?
Yep. I kept it pretty, well, actually, because all of this is outbound, so your security group configuration on this endpoint is going to be like pretty much the default, because by default, outbound is open, inbound is completely closed. So even if you kind of put an empty security group, outbound is going to be allowed, so you'll be able to send the queries out and forward. It's a different story if we're going to look at the inbound endpoint where you're actually receiving queries from elsewhere, and that's where you need to make sure you're allowing that traffic correctly.
Okay. And Tech First is saying for outbound rules to work, default DNS of the VPC has to be the .2, right? Do you want to talk to that?
Yes, correct. So the rules only apply if the query comes to Route 53 resolver, so the .2 IP address. If I've configured my VPC to use, I don't know, a third-party DNS inside of the VPC or something's located somewhere else, none of this applies anymore, right? The rules, Route 53 resolver is not seeing the query, so it can't apply the rules and can't apply any logic on top of what it's doing. So totally right. You have to use the .2 to be able to rely on the rules.
Okay. What else we got here? Does the resolver endpoint have some cache, or is it always send requests to the DNS server?
I think I'd have to double check. I think there's a certain amount of cache on the EC2 instance itself, for sure. I think the resolver is going to do some cache. I can't remember exactly the numbers. I think it's documented somewhere, but there is going to be a little bit of caching in each layer here.
Okay, a lot of questions today. Ken has some questions. 3 questions. How would you tackle reverse lookups zoned to resolve IPs in a custom domain, not the compute.internal?
Yeah, you can. So by default, the reverse lookups for the VPC CIDR range are kind of taking over, but by hidden rules. So there's a bunch of auto-defined rules or hidden rules that AWS creates for you when you set up a VPC, and all of the reverse rules, which means rules for the IP address. So if you do a DNS lookup on an IP address or on a kind of a pointer record for an IP address, you'll get the answer in the VPC automatically. You can override those. There's ways to do it where you could disable them in the VPC and then create your own rules that you would say, I want to forward any pointer rules for resolving IP addresses back to on-premise, and then I have a zone on-premise. So it's doable. You can certainly set that up. You just need to do 2 things: set up your forwarding and then disable that default behavior on the VPC. I think we might actually be able to, can't remember where that it's configured. I think it's here. Yeah, auto-defined reverse. Yeah. So if we look at the VPC here, you can see, right now you can also see I've added the outbound rule here. So there's a default internet resolver rule that's always there. And then this extra example internal rule that deals with, and by the way, we're looking at the VPC, the workload VPC. Right? I haven't configured any query logging, but I have 2 rules. One just dealing with internet resolution, and then for example.internal, I want to forward to on-premise via this endpoint. I don't have any inbound endpoints. I haven't set up a firewall. I haven't set up any special rules for fail open for the firewall. DNSSEC is disabled. And here are the auto-defined rules for reverse DNS resolution. So by default, we're kind of hijacking those, or maybe not hijacking, by taking care of them for you. You can disable that behavior and forward those elsewhere. So it's possible.
Okay, Ken's second question. What resolver would you use if using Microsoft Active Directory?
Oh yeah, that's a nice
Who
question.
or AD?
Yeah, it comes up a lot, and as well, it runs into. I can probably draw some examples of challenges for it, but maybe, what, let me see how we're doing on time. Maybe let's do a quick completion of the demo. So everything should be configured now. So if I'm here and I would just do naked DNS resolution for main.example and not point it to the on-premise DNS, but use my Route 53 resolver, now I'm getting the correct answer. And you can see it's coming from Route 53 resolver. If I do, I think we had www. That's also resolving. If we look at let me show you the EC2 instance that is hosting the DNS. That is the on-premise DNS server. We connect to it again. And we do a TCP dump to show you the source IP address from which this query is actually coming. Sudo TCP dump port 53. I think that should be enough. So then if I have my EC2 instance and I do another query, there we go. Okay, did it come through, or was it? I think I might have been cached. Let me try again. 11 more seconds. I can't remember if there's another record. Was it NS? There we go. Oops. So this is all the DNS resolution that the instance is doing itself. So it's adding a little bit of noise. But we can see here that there was a query from 10.0.132.1. That is not the IP address of the EC2 instance. That is the IP address of the outbound endpoint. So we can see that going back into the Route 53 section. And looking at the outbound endpoints. and looking at the IPS 132.1. Right, so that is what was forwarding, and we have also 895. That is, both of these were being used to forward DNS queries to that on-premise server. So what
Is there
happened?
any rhyme or reason on which it will actually choose?
I think it's just going to distribute the requests. I can't remember if there's additional logic other than random, but it will use multiples. But I can't remember the details of how exactly is the logic distributed there. We can double check. I know that if you have multiple destinations, I think that's going to be doing random. So if I have right now, I have only a single server out here, but if I could have multiple bind servers, so it would use multiples at random. Okay, so I know there was a question about
So
Active
back
Directory.
to the questions. There was the question from Ken, would use Microsoft AD.
Yep.
Also, Hitherings, I think, which is related, saying we use the .2 resolver with a forward rule to AD for anything about local domain.
That's the way to do
about
it.
the local domain.
That's the way to do it. So there's two ways that I've seen customers do it. So let's say they have AD inside of this VPC. And maybe let's clean up all of the blue stuff for now. So we know that works. Outbound DNS resolution works. I'm just going to clean this up a little bit, and we can add make some room and add the Active Directory in red. Okay. So say we have Active Directory in this VPC. You could either configure everything in the VPC to use Active Directory as the primary and then have the Active Directory forward queries to the .2. The challenge with that is the queries per second limit on that flow from a single EC2 instance to Route 53 resolver is 1,000. I think it's 1,026, but let's say it's 1,000. So it means if you have a lot of EC2 instances and they're all sending requests to the AD, and then AD is the aggregator that is then forwarding all of these, it's actually quite easy to hit the 1,000 queries per second in that model. The other problem that occurs is, what do you do if you have other VPCs? So say I have 100 other VPCs, right? And all of them need to talk to AD. Okay, so I have an EC2 instance, and you told that EC2 instance that this is its primary DNS, this Active Directory IP address, whatever that's going to be. And then that will forward to the .2. Now, what if in this VPC you have a private hosted zone? So private hosted zone is a private DNS domain that is only visible to the VPC that it's attached to. So that's some private hosted zone that I've created. Sometimes for some services like endpoints, like VPC endpoints for AWS services, would automatically create those private hosted zones inside the VPC where you deploy the endpoint, right? So there could be an endpoint here, and this is a private hosted zone for it, or it's a private hosted zone that you created that just governs DNS in that VPC. You're never going to see it because all of your DNS queries are going to the Active Directory and use the DNS resolver in the VPC where the Active Directory is. So it can only see the private hosted zones that are attached to this VPC, not the private hosted zones attached to this VPC. So you end up having to make sure that this private hosted zone is also in here, and it becomes complicated if you have split horizon, so different resolution for the same zone, for the same domain. It just becomes super complicated. So even though technically it works, there's some challenges there. A better model that you can go for is let me delete this and delete this and put the Active Directory back in the game. So a better model is continue using your resolver, but then you can have a rule even for all of your DNS resolution, right? So have a dot rule. A dot rule is basically going to say, hey, whatever DNS query this is for, forward it to the destination of your choice. So set up forwarding for any DNS or for specific domains that the Active Directory takes care of. But if you want Active Directory to see all of the DNS, forward this way. So what's going to happen is you will have the endpoint like we had before. This query would hit with the resolver, then it would use the endpoint to go back to the Active Directory. So Active Directory still sees all of the DNS queries, but it's not receiving them directly. It's not becoming a bottleneck for the DNS queries. All of the EC2 instances go to .2, and then whatever is the rule. The broadest one is the dot, but you can have a more granular rule forwarding stuff to the Active Directory. And this works really well across VPCs as well. So if I have an EC2 instance here, I could say, hey, I want the same rule that I have here on this VPC, and it will be able to forward the query for the same endpoint and get it to the Active Directory. So now I have, from any VPC, ability to forward queries to the Active Directory. And you can ask, what about the private hosted zones? So now if I have a private hosted zone here, or private hosted zone attached to this VPC, that will always take precedence against a more broad rule. So for private hosted zones, for maybe AWS services, so if you created an endpoint for CloudWatch, right, cloudwatch.amazonaws.com, we create this host name for you, or the domain or private hosted zone for you automatically, and attach it to the VPC where you have the CloudWatch endpoint, so that the IP addresses that you get back are going to be private. Again, that only works in the VPC where you have the endpoint. And right now it's going to work because the EC2 instance hits the .2, is able to see that there's a private hosted zone and get a response back without forwarding, but everything else is going to get forwarded by the dot rule. And same thing applies to all the other VPCs. Those private hosted zones with other VPCs just work perfectly, while any other queries get forwarded to the AD. And you can also replace the Active Directory with any other third-party DNS resolution service, even something that you have on premise. That forwarding model is very flexible there.
Okay, comprehensive answer. Third question from Ken. We've got a bunch of questions in here. This is great. Keep it up, folks. How would you tackle split DNS?
Yeah, so those are the private hosted zones. So split DNS, let's actually do that in the demo. So I can have a hosted zone, create a hosted zone. This is going to be bbc.com. And I don't own it, right? Obviously, BBC owns it. I can choose my region. Where am I? I think I was in Oregon. And I can attach this to a specific VPC, which I'm going to attach it to my workload VPC and create a hosted zone. And I'm going to say create a record. So now www.bbc.com is going to return 1234. Create record. All right. So if I'm going to open this is my laptop, and we'll do a dig for www.bbc.com. I get a bunch of IP addresses here, right? It's all nice. I get a proper response. So on my EC2 instance, what I did, I just attached this private hosted zone that I created to my VPC. So this private hosted zone now, the other one that I might have here right now is bbc.com. And I have one record that says www equals 1234. So we'll see how that works inside of my VPC. This is my workload instance. If I do dig on www.bbc.com, it's still working. Let's see what's happening. Associated VPC. Let me just double check if it's the right VPC. I'm gonna do some live troubleshooting. I was too blasé about this working, and I'm paying the price.
We have about 5 minutes left, so
yeah, it is the right
we'll
VPC.
See how you go.
Let's see. Let's double check the VPC as well.
Dinesh says BBC is probably coming from the cache.
I haven't resolved it before, so it shouldn't have come from the cache. That would be the case if I did the resolution before, but this is the first time I'm resolving this. And I think I did bbc.com, right? This is the how to define rules, endpoints, rules, hosted zones, bbc.com. I think that's the right VPC. And the record's correct. Maybe it's just taking a while. Okay, yeah, I just needed a while to kick in. So I did it again and it's working. Yeah, okay. So now we're overriding bbc.com. So that actually worked out perfectly because we managed to catch it while it still was working. And now the private hosted zone kicked into the VPC and we're overriding that. So this is the split horizon DNS or split view DNS where you can put a private hosted zone inside of the VPC and override any public behavior. One thing to call out here is that I've lost connectivity, right? If I need I've set up a bbc.com domain. If I need other records, so if I need, I don't know, video.bbc.com to work publicly, but www should resolve privately, I need to create a more specific zone to be able to do that. Otherwise, because I created bbc.com, there's no fallback. I've just ruined everything that's starting with BBC, ending, sorry, with BBC. So any host names that end with bbc.com have to be governed by this private hosted zone I just created.
All right. Very cool.
Any other
We have
questions in
yeah,
the
we have
chat?
a bunch actually.
I know we have 9 minutes left, so I wonder if
Wait,
I wanted
I,
to
I,
show the inbound endpoint, but I guess that's going to be simpler than anything else. So we can probably tackle the questions if for another
well, I
5
think we have
minutes.
to end a little early as well. So I think we're pretty tight. I'm just scanning the questions here. So real quick, Dinesh is asking if there's a way to set up a kind of DOS attack against example.internal site.
You mean, well, in a way, by setting up this private hosted zone, so being able to manage private hosted zones gives you a lot of power, right? Because if this VPC, my workload VPC really needed to talk to bbc.com, and I just went in, created a private hosted zone and overridden the behavior to point to whatever I wanted to point to, that's a lot of power to have. So I could have completely DOSed this access to, www.bbc.com. Maybe it's a critical access. So you really want to make sure that you're using IAM to control who has the ability to mess around with network configurations in general. I guess if the question is DOSed in terms of, I'm assuming the question means DOSed in terms of, overriding a working DNS. If we're talking about forwarding to on-premise, yeah, if you have a lot of sources and you only have one tiny server on-premise that's, sweating already, if you start hammering it from a lot of different sources, you need to think about ways to scale.
Okay, and so Sankit was asking previously, will it add latency? And I think this is referring to resolving to on-premises.
Yeah, if you're forwarding to on-premise, the latency is
Forward.
definitely going to be longer than if you're resolving locally on the Route 53 resolver.
Okay, and along that same grain, TechFueled saying this architecture relies on layer 3 connectivity to work to on-premise DNS. How is it better than setting up conditional forwarder?
Yeah, that's actually a good question. So it is in a way, this is a conditional forwarder, but on a VPC level, right? So you're doing conditional forwarding on a VPC level, and you can be selective on what is it that you're forwarding. And you're right to say that whatever you're forwarding is now dependent on the network connectivity. So if your network connectivity drops, anything you are forwarding is now gone. But you have the ability to control very granularly what is it that you're forwarding. So you can only forward example.internal. And if say connectivity failed, you can't resolve example.internal, but you probably also can't get to anything that's behind the example.internal because probably all those things live on premise anyway. So you have to ultimately at that point you have a complete loss of connectivity to anything on premise, but all the other DNS is still working. So if you're talking within the VPCs, you're talking to something that's on public internet, connecting to GitHub, all of that is still going to work while you're fixing whatever happened with your network connectivity. So you're right to say that there's a dependency you're creating with on the network and on-premise DNS resolution. So if you can avoid that, that's always better. But in many scenarios, you will have on-prem infrastructure that you need to be able to send queries to. And the best thing you can do is make sure it's as highly available as possible, right? So if it's direct connect, have align with the 9.4s of SLA of availability. Make sure you have multiple DNS servers on the back end as well that can handle the traffic, things like that.
Everything fails all the time. Always build redundancy where you can.
Yeah.
There's a question here. Well, Sanket's making a comment here about will tracing, I think that was a typo, will tracing DNS failures be harder across a hybrid network? I mean, you've got more components here, but...
Yeah. I guess you need to be aware that it's like with any network connectivity, right? The more components in the path, the more things that can fail, the more things that you need to investigate when there is an issue, right? So you would start from, okay, I can't resolve something on premise. First of all, you need to investigate because you might find I can't resolve examples of internal. So you need to look at workload VPC and go, actually, I've been forwarding, or whoever set this up, the administrator, has been forwarding those queries to on-premise, and that's not something that's being resolved publicly or locally in the VPC. So now I need to trace the path and kind of follow all the steps. But it's just like with any other connectivity construct. So yeah.
And a follow-on question from Sanket was, can we add DNS IPs to etc. resolve.conf in EC2? I mean, you own the EC2 instance, so
you can, yeah. You don't want to bypass the dot to resolver. So I would say bypassing the dot to resolver is a world of pain in setting up things inside of AWS. So a rule of thumb is even if you have requirements to forward traffic to a third-party DNS somewhere or an Active Directory, send all of your queries to the Route 53 resolver and then let it decide what to do next. The other reason, so one of the reasons I mentioned was private hosted zones. There's also one other reason that I haven't mentioned is some services have AZ-aware responses from DNS. So if you're talking to Elastic File Storage, EFS, that when you do a DNS lookup on the endpoint for that, it will give you the IP address of your local AZ, meaning that if you're then sending files, you're going to have the lowest latency and the lowest cost. If you disable that, you're going to get a bunch of IP addresses. You pick one at random, and what might happen is for something that could have been free, you're now sending data across AZs, and you're not only adding latency, but you're paying extra. So there's a bunch of cool features that Route 53 Resolver has that if you don't point to it, you're going to lose all of that, and then yeah, it's going to make your life complicated.
I think that's definitely a fair comment. We've got we have about a minute here. Maybe we can do the last three questions real quick. Can we have multi-cloud DNS as well? I mean, where your on-premises bind server is, it could be in another cloud, right? I mean,
correct. Yeah, it's just DNS forwarding. So you're specifying IP addresses. As long as you can reach the DNS in the other cloud provider, you can do it. We have an option for you to present your DNS through an endpoint. So we talked about the outbound endpoint. We didn't talk about an inbound endpoint that allows you to send DNS queries to AWS from elsewhere. So it's totally feasible. You should be able to do multi-cloud. And I know we have like a minute left, and I think we have to start closing it.
Single outbound or inbound endpoint works for all VPCs without peering between them?
Oh, yes. So that's another interesting, I think there's a big misconception that you need to be able to connect these VPCs to this VPC to be able to use the outbound endpoint. That's not the case. So even if I didn't have a transit gateway, but I configured a rule on these VPCs, I can still get the use of this outbound endpoint to connect to on-premise. So DNS path is going to be different to the data plane path, and AWS takes care of that DNS path. So this connectivity, all of this doesn't need to exist. I can still send a query from the EC2 instance.
We're out of time, friend.
Oh.
You're too comprehensive with your answers, but look, I think there was one last question from Ken. Is there a way to transfer zones for PHS? Maybe we can take that next week. Sanket and Hitherings and Ken, everyone says they really like the session, so I did too. I learned a bunch as well. Thank you so much.
Awesome.
We'll see you folks next week.
We're not there next week or the week after.
Oh,
we have
that's
DC
right.
Summit and Reinforce, but we'll be back in 3 weeks.
we'll see you folks in 3 weeks. Thanks all. Thanks, Tom. Thanks so much.
Cool. Thanks, everybody.